Hey, we have here on the board another interesting integral. I've got the integral of 1 over sine squared x plus 1 dx. Okay, the thing I thought that was really interesting about this is that for a very simple looking expression, we don't really have anything to do a u substitution with, and there's not really an obvious trig identity to help us here. For a second, I thought maybe I could think of it like we've got a 1 in the numerator, if I could write that as sine squared x plus cosine squared x, but that didn't really seem to help all that much. So what I tried next, instead of trying to work with sine and cosine, let's see if we could work with tan and secant. And so what I could do for that is I can just multiply my numerator and denominator by secant squared x. And so when we do that, we'll just have secant squared in the numerator. Then secant squared is 1 over cosine squared times sine squared. This is going to give me tan squared x right here. And then we're just going to have plus secant squared x. But for this, I can use the identity that secant squared x is the same thing as 1 plus tan squared x. So I can rewrite this and I can add this to my tan squared. So in the denominator, what I'll have is we'll have 2 tan squared x plus 1, and then we'll still have our secant squared x here. But now at this point, because the derivative of tangent is secant squared, now we're actually in good shape for a u substitution. So what I'm going to do is I'm going to call my u just equal to tan x. And then my derivative is going to be secant squared x dx. So we have our du right here. And let's make that substitution. So I'm just going to have du over 2u squared plus 1. And then I'll factor this 2 out in the denominator, so I'll write it as 1/2 in front. And we'll have du u squared plus 1/2. I'm going to write the 1/2 as 1 square root of 2 squared. But now this integral is set up for arctan. So let's just look at that formula really quick. Okay, I've got my arctan formula over here on the left, and you'll see that we're in the right form here with our u squared, and then our a value here. This a value is going to be 1 over square root of 2. So let's just get our solution in terms of u. So let's just bring the 1/2 in front. We're going to have 1 over a, which is this 1 over square root of 2. So the reciprocal, this is going to give me just square root of 2. Then we're going to have our arctan. For the variable, we're going to have u over 1 over square root of 2, but again, it's going to be reciprocal, so we're going to have square root of 2u. And so all I'm going to need to do is just back substitute to finish this off. So for the final solution, we're going to have square root of 2 over 2 arctan square root of 2 tan x plus c, and that's it. Okay, I thought it was a good problem. It really relied on this first step of just multiplying in by the secants, and then after that it was pretty easy. So we will stop it there. Thanks everyone for watching today. Have a great day.